Recording in progress.
Yep, camps on everyone. Let's start off. So last class we have done the free body diagrams. Right. So the next part is equilibrium. Now this we have done in vectors also. So what is equilibrium? A body is said to be in equilibrium if net force is 0. Now be careful. When I say body is in equilibrium, doesn't mean it won't move. A body can have constant velocity in equilibrium. Because if the net force is 0, means acceleration is 0, means you can have a constant velocity. So they ask a question like this: if the body is at rest, meaning it is in equilibrium, but if a body is in equilibrium, it need not be at rest. Clear? So keep that in mind. Simple question, but yeah. So if you have a body here with forces F1 bar, F2 bar, F3 bar, and F1 bar plus F2 bar plus F3 bar is 0 vector. If a body is in equilibrium, component of forces in any direction. So if you say a system is in equilibrium, you can take forces, you can take the components in any direction, will cancel out. The simple reason, if they don't cancel out means what? The body will move in that direction, but that means it's not in equilibrium. Just to give an example, suppose if I just draw a random line like this, so if I take F1 ka component, F2 ka component, and F3 ka component, they should cancel out along the line. So have a look at this. Now, if you remember, we did exactly the same thing in vectors also. Clear this page. Next thing. So how do we solve problems? Now things will move in the next class, but today also things are still at rest, but we will start using the FBDs especially today. So steps to solve. Now any problem in LLM, these are the steps which you follow. Step 1, choose your system and draw an FBD. Now how to choose a system is completely your choice. If there are two bodies A, B, you can take A as a system, you can take B as a system, you can take A and B also as a system. Choose your system and draw an FBD. How to draw FBD? For that also we wrote steps in the last class. So it's like an algo ke answer, there's a smaller algorithm. Step 2, choose your X and Y axis. Or let's say assign accelerations. Let's say there are 4 bodies, assign accelerations A1, A2, A3, A4, and find the relation between them using constraints. Now constraints we have studied. So step 1, you learned how to draw FBDs. Step 2, you learned how to draw, constraints. Step 3, choose your X and Y axis. You can choose any two perpendicular lines as x and y axis. Resolve the forces and accelerations along x and y. This you learned in vectors, how to resolve components. Step 4, apply F is equal to ma along the both axes. So all forces in x direction will give you mass into acceleration in x direction. All forces in y direction will give you mass into acceleration in y direction. Now, if you say system is in equilibrium, A will be 0. So equilibrium is a special case where A is 0. That's it. These are the main steps. No matter how complex it is, you're going to use all this to solve all problems. If system is in equilibrium, then acceleration is 0. That is F net is 0. So for equilibrium problems, step 2, we won't use. So we'll draw an FBD. We will resolve the forces. We will not, there's no acceleration. And then we'll apply net force is 0. So 1, 3, and 4 is what we use. Step 2 is not necessary for, not important for equilibrium because nothing is moving. There's no constraints, all are 0. Please have a look at the steps. Do check out the steps. Clear? Let's see some questions. Let's start off with something easy. This is small m, this is capital M. Find m by m for equilibrium. There. I hope the diagram is clear. Find the value of m by m if the system is at rest. Try 2 minutes and I'll show you. The steps are same. Step 1, choose a system. There are 2 blocks. I need to draw 2 FBDs. Step 2, constant equation. There's no constants here, so step 2 is gone. Step 3, resolve the forces along x and y. Yeah, it's only going up and down, so there's no resolution here as such. Then net force is 0. Take a minute. I'll show you in a minute. The first one. Let me show the first one. So let's start from anywhere. I will take this as tension T. You can take any string as T, it doesn't matter. End of that is a ratio, it will get cancelled out. This is also T, this is also T, and this is small mg. So you can clearly see here, three times tension is balancing small mg. It is an equilibrium. And if that is T, this is T, this will be double tension, and this will be 2T. This will be 4T, and this will be 4T. And this would be capital Mg. So we'll have 7T is equal to capital Mg. You're done, equate them. So mg by 7 is equal to small mg by 3. So m by small m is 7:3. So we got tension here is mg by 3. And here we got tension is equal to mg by 7. Both should be equal. Easy. Since it is an equilibrium, net upward force is equal to net downward force. So all three tensions are balancing 1 mg. Now how do you do the second part? Try. I'll give you a minute. Idea is the same. But here there's an incline also now. Think, take a minute. Okay, let me show you the components first. This I taught you in projectile on an inclined. So whenever you have this incline here, this you can remember this. This is mass m, this is theta. So if this was your mg, if that was theta, this would be theta. This would be 90 minus theta. So if you look at the components here, this would be mg cos theta, and this would be mg sin theta. So there. So whenever you have block and an incline, the components are mg sin theta and this. So if I draw the FBD, this will be mg sin theta, mg cos theta. This would be normal reaction. This is tension. Since it is in equilibrium, tension must be equal to mg sin theta. It is the same tension here. So this would be tension, tension. This would be tension. This would be tension. Be careful, the string has changed, and this is tension. And this is small mg. So there are 5 tensions there. So 5T is equal to small mg. So take this tension and substitute here. So this will be 5 mg sine theta is equal to small mg. Yeah, so m by m will be 1 by 5 sine theta or cosecant theta by 5. Check. Here you have to be careful. There are 2 strings here. If you see, this entire red thing is a string. The string changed there. There are total 5 tensions pulling it up. Have a look at the diagram. Clear with this? Let's see one more. Any doubts on this? Anyone not clear with the steps, please ask me. You have learned how to draw FBDs, you learned how to draw components. Now everything is combining together. So we have a sphere and a wedge. Mass is 2m. Wedge ka mass is m. Angle theta. All surfaces are smooth. So if you leave it like this, what will happen? What will happen to the wedge? Will it remain there? It will start going back, right? So someone has to apply force to keep it in equilibrium. So the question is, find F if system is at rest. If you don't want the ball to slide down, why didn't we consider the string connected to the center of the book? Arre God, it is the same string, na re? This 2t only will come here, na 2t. Right, Arya? Same thing, na? तो वो दोनों connected तो मैंने वो consider नहीं किया.
Okay, sir.
Meaning you want to say that, then I will say this is 2t. Fair?
Okay, sir.
Yeah. So let's get this. Find F if the system is at rest. Now think about what happens. If you don't apply enough force, the wedge will come back, the ball will drop. If you apply too much force, wedge will go forward, the ball will go up. So there is a particular amount of force if you apply, system will just be at rest. Let's get this, everyone. This free body diagram we have drawn. Now we are solving it. So today we are not moving many of the things, but slowly we are just bumping up. Let's get this, everyone. Remember the process. Step 1, draw the free body diagrams. Step 2, assign accelerations. There's not there. Step 3, resolve the forces along the directions. Step 4, net force is 0 in any direction. Try 2 minutes, then I'll show you. Then you can see what went wrong in case you didn't get it. Mg tan theta 2mg plus mg sin theta. Ng2 sine theta. We have three different answers. Let's see. Step one, FBD. Let's see whether you got the FBDs right. This is N wall. Remember, normal solid is passed through the center. This is N. This is Mg. This is also N, the same N basically. You need not draw like this, but just that I'm showing you. And the wedge ka mass is Mg. Yeah, 2 Mg a ball ka. This is F. Now this angle is theta. So if I extend this angle would be 90 minus theta. And you can clearly see here, that means this angle is also theta. And now look at the components here. So this would be N cos theta. This would be N sine theta. So be careful with the angles and stuff. Similarly, this N ka components also N cos theta. The vertical component is also N sine theta. Check. After drawing FBDs, so resolve them into components. Now for the ball, if you see the vertical direction along y-axis, what are the forces? N sine theta is balancing 2 mg. And the horizontal N cos theta is balancing N wall. I didn't ask you that, but okay. And then from here we'll get N is equal to 2 mg by sine theta. This is the y-axis. This is the x-axis. Forces along x is 0, forces along y is 0. Now for the wedge, we are only interested in F, so x-axis only I will take. If you see here, the only force which is supporting F is N sine theta. There is no one else. F is equal to N sine. I goofed up something, no? I goofed up. This was reverse. This was N cos theta. This was N sine theta. Take this and put it here. This would be 2 mg sine theta by cos theta. 2 mg tan theta. Easy? Check it out. Draw the FBD, resolve the forces along x and y. So you need to take the angles properly. So have a look at those angles in case you're confused. Normal is always perpendicular. So this angle is 90 degrees here. If that is theta, that is 90 minus theta, and that is theta, and so on. Let's see one more. Any doubts on this? Next one. This is small m, this is capital M, this is theta. Again, all surfaces are smooth. So if you leave this, the big one will actually go to the right side. The small block will slide down, pulling this thing. So to keep this at rest, someone has to apply a force F. So the question is find F and normal reaction between wedge and the ground. meaning this normal reaction I want, wedge and the ground, if system is at rest. You need to apply force or else this won't remain at rest, it will slide. And find the normal reaction between the ground and the wedge. Let's get this. This FBD also you know how to draw. Any answers? Now, remember the first step what I said, choose your system and draw your FBD. You know why I keep writing those things, steps to draw an FBD, steps to solve and everything. What happens, right, when you go to an exam, you see a question, you blank out. You're like, what? Oh, it looks so big. When you know the steps, whatever is the question, don't worry, you start drawing an FBD. The moment you draw an FBD, you will see something there. Rosa got something. What about normal on the ground? Let's see. Now, listen to this thing carefully. What you choose as a system makes a lot of difference. This is what I keep saying, how to do, but by choosing, when you're having a different choices, things will become easy for you. Now, what I will do here, my system, right? I will take both of them as one system. You getting? So choose, and I'll show you what happens if you take them separately also. Choose M and small m as one system. So the advantage of this thing is whatever is the forces between them, everything will cancel out, isn't it? Now just think of like this, like, just put a black cloth on this and close everything. You don't know what is there inside. What do you see here? If you take the whole thing as a system, what do you notice? You will see there is a tension here, there is a tension here, there is a tension here, there is a tension here. Tension. You have a weight mg, you have block a weight small mg, and there is a n on the ground, isn't it? every force between them, so this tension here and this tension here will cancel. This normal reaction here and this normal reaction here will cancel. So all of them will become internal forces. So all forces between m and small m cancel out. Newton's third law. These are called internal forces. Meaning, if I close the whole thing with a black cloth, you don't know what is happening inside. Now, if this is my system, and if I ask you to draw the forces, what will you say? F is equal to phi times tension, isn't it? And the normal reaction on the ground will be m plus mg. That second part of the question, I got it in one step. Because for the system, if you see, the only person who is balancing all this weight is the normal on the ground, isn't it? There is no one else who is balancing the weight. These strings will not balance any weight. We still didn't find the tension though. Abhi iske liye now I will draw only small m as an FBD. You can choose anyone as a system. I'll choose the whole thing as a system and I'll choose small m as a system. Now, tension. These components are mg sine theta. Let's call this ng. This is n and this is mg cos theta. So from here we get tension is equal to mg sine theta. Take this and substitute here. So this is F is equal to 5 small mg sine theta. And that's your answer. Now let's see what happens if I take each of them as individual system and solve. But have a look at this. This is one way. So it is your choice how you want to take a system. By choosing system in a certain way, sometimes it becomes much easier to solve. So blindly every time, I never said choose each block as a system. I said choose your system. So I can choose M as a system. I can choose small m as a system. I can choose m plus m as a system. Clear with this? Now let's see what happens if I try to do this individually. Individually, if you try to do that, you'll get the answer. It becomes slightly more complex. What are the forces? We'll have tension, 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 T, tension, normal reaction. Capital Mg, N ground, and F. This would be T. This would be Mg sine theta. This would be N, and this would be Mg cos theta. So from here, T will be equal to small mg sine theta. Those two should balance. It's an equilibrium. And N is equal to mg cos theta. Now here, if you look at the components, if this is theta, this is theta, this is theta. So this component would be n cos theta. This component would be n sine theta. This component would be t cos theta. This component would be t sine theta. Now, in the horizontal direction, the forces are F is on the left-hand side. So all the forces acting on the left must be equal to all the forces acting on the right. So I'll take right positive, left negative, same convention we did there. So 1, 2, 3, 4, 5 tensions to the right. 5t plus there's one t cos theta also is to the right. Minus n sine theta minus f, total force is 0. And in the vertical direction, so substitute here now. This is 5t plus t cos theta. What is n? N is mg cos theta. T का value भी substitute कर सकते हैं ना. That would be 5 mg sine theta. This is mg sine theta cos theta. What is n? N is also mg cos theta sine theta minus f equal to 0. This term cancels off. F is equal to 5 mg sine theta. Same answer. But you saw it was a little lengthy. What about vertical? N ground would be capital Mg plus t sine theta plus n cos theta. Again substitute. This would be mg sine square theta. N would be mg cos square theta. Sine square theta plus cos square theta is 1. So mg plus small mg. So if you write them individually, you'll get the same answer, but you can see the headache, right? This tension ka and n ka components are coming and it is becoming lengthy. But if you choose a system like this, makes your life easy. Answers will always come. But how much time are you spending also makes sense. So choosing your system in a proper way will make your life easy. Now, how will you know system is a choose karna hai? Now, these are the things which you can't be taught. These things come only when you do enough practice. A certain kind of techniques, right? Only when you solve like 10, 15 models every time, then you'll get an idea. Okay, whenever something like this comes, I could have handled like this. That is what we call as experience. So experience can't be taught by, reading books or by doing anything. That is the reason we keep telling you to solve problems. All clear with this? Let's see one more. Any doubts on this? Please ask me. There, I didn't do anything new. You know how to draw FBDs. You know how to resolve components. And you know net force is zero to balance the forces. Let's see one more. So we have a system like this. All these are strings. Blocks M1, M2, M3 are connected by strings. This angle be alpha, this angle be beta, and this angle be gamma. I want you to find tension in the upper string. Gravity is there. Find tension T in the uppermost string.
Sorry, same string.
They are not same strings. यहाँ पे connection है ना? How can it be same string? Same string matlab there should be nothing in the middle. If you tie one more string like this, the string changes. I hope everyone is getting that. If you have like this is the same string, but if you put like one more rope here like this, वो change हो गया string दोनों side. Because when you put one more string in the middle, it is also pulling, na? So the tension will change on both the sides. Strings are massless. If strings are mass, I will tell you. Generally, always assume strings are massless until and unless mentioned. Ideal strings.
So M1, M2, and M3 are at rest.
Yeah, where will they go? They have to break the strings and go if they want to move. Everything is at rest. System is at rest. Now, this is a shock question. Matlab, M1, M2, M3, alpha, beta, gamma. I said, like, what the hell? That is a feeling generally when people get when they see in the exam. When you see something like this, you should understand. The examiner knows if you try to solve this normally, it will take 10 minutes. But you can solve this in less than a minute. So you should know how to handle that. Try. I'll give you 2 minutes. Yeah. So see, we did this in foundation, remember? Something like this. Like I said, how you choose your system will make your life easy. So I will choose the entire thing as one system. Now, if you take the entire thing as one system, you don't know what is happening inside, we don't care. Now, if you look at your forces here, this is T1, I don't know. This is T2, I don't know. This is T3, I don't know. The total weight is M1G. This weight is M2G. This weight is M3G. And if you look at here, the components, this is T, this is gamma. So the vertical component would be T sine gamma, and the horizontal component is T cos gamma. Now, in the whole system, if you can see, the only force which balances the total weight is T sine alpha. That is balancing the overall weight M1 plus M2 plus M3 into G. The T cos gamma is managing, this is T cosine gamma. Because T1, T2, T3 are horizontal forces, they will never balance weight, isn't it? Anything in the horizontal will not affect anything in the vertical direction. Done. There, you got the answer in one step. Is that making sense, everyone? That's it. So you don't need to find tensions in any string or anything. Take the whole thing as one system. Take M1, M2, M3 as one system. This is what I was saying. Depending on how you use the system, your life can make it easy. If you try to solve individual block, you will die. All clear with this? Let's see one more. Any doubts on this? Clear with this, Daniel? Arya? Abhinav? Clear? Adi? Got this?
सर
हाँ देवांश
ये राइट वॉल को भी सिस्टम में क्यों नहीं ले सकते थे
ले लेना. Then write the forces between Earth and this thing also.
अर्थ
Then wall कहाँ पे connected है? Wall हवा पे है क्या? Where is the wall connected to? Where is the wall? बोलो ना देवांश. Wall should be somewhere, right? Where is the wall? It is with the Earth. Then you'll say, sir, Earth को भी system लेते हैं. चलेगा ना. But who is attracting Earth? Sun. तो sun को भी लेते हैं. Then you'll say, sir, sun को भी लेते हैं. But sun is also being attracted by the galaxy. So we'll take the galaxy का center, black hole. And then sir, you'll say, galaxy को कौन pull करे? Then we'll take God also, God force. There, that is the catch. You can take the wall, but you don't know the forces between the wall and the Earth. Adi, clear with this? Yeah. Next one. Generally, don't include walls and stuff because a wall must be connected to something. We don't know what it is, so that will be unknown. I should draw small circles, I guess. There we have three identical balls, A, B, C. All spheres have mass m and radius r, so identical. The distance between them is 3r. So let's number the points. So this is point contact 1, this is contact 2, contact 3, contact 4, contact 5, and contact 6. So it is touching 6 places. So there are 6 normal reactions. Find all normal reactions. System is at rest. Let's get them. We have drawn the FBD for this. You have three spheres of same mass, same radius. The distance between the walls is 3r, and they're like this in equilibrium. Think how will you do this thing? It's a good one. This is a kind of a question you can get it in a paragraph or a matrix matching, or more than one choice question. No, listen to me once. Before solving, right, between the six, there is one normal reaction you can find without doing anything. You can just see and tell the answer. Which one is it and how much is it?
Sir, C ka.
You can just type in the group, Nare, Ansh. Let others also try. I know you want to give the answer and make sure others don't think and make sure their rank goes off, but it's a good strategy. Type your answer in the chat box. Let others also think of it. If you have an answer, do type in the chat box to the co-host. You have a doubt, please unmute and ask. There is no problem if you have doubts. But answers, let everyone also think. Kya tha? Out of the 6 normal reactions, again, listen what I'm saying. This is what I'm saying. Na? Don't always jump into solving question. They go like, what else I would have done much faster? Which normal reaction? There is one normal reaction you can just see and tell the answer. Which one is it and how much is it? I number the points, right? You can tell me the numbers. 1, 2, 3, 4, 5, 6. Which one? Yeah, Ahana got the answer. Ansh, you are saying it, but your answer is wrong. How much is the answer? Which point you can find and how much is that? नहीं Arya, that's not the answer. हाँ वो ठीक है अभी नो, but answer कितना है उसका? So if you say you can find, what is the answer then? Anyone? Right, Poroja, you got it. हाँ अंश, answer कितना था? You got the point right though. Yeah, right, Rehan. See, if I take the whole thing as one system, all these forces are horizontal. The only person who is applying an upward force is the N on the N6, which is supporting this mg, this mg, this mg, isn't it? So N6 is 3 mg, na? The total weight of the balls is supported by one normal reaction on the ground. Total weight lena tha, not only C ka weight. Is that making sense? So choosing the whole thing as a system makes your life easy. You can just find N6 directly without doing anything. There, you got N6. Get the remaining. That would help to eliminate options in the exam. So if I'm solving this question in the exam, agar options mein, they say N6 is 2 mg, I know it is wrong. Try. How will you try? FBDs. This process is the same. Choose a system, draw an FBD, resolve forces along X and Y, and then equate them, and you're done.
सर ये फोर्थ वाला पॉइंट डायमीटर
Fourth point of contact, right? Where will two spheres touch? The diagram is not up to scale, so draw कर ले. But identical बोला ना मैंने. I didn't draw them properly. I draw C little small, so two spheres will always touch at a single point, right? The normal will be perpendicular along to the center to center. The diagram is not up to scale, so think. You guys must have got stuck for an angle. You need to find an angle. Why do you think I gave that 3R? Geometry hai. There is an angle you need to figure out. I think that we did in basic maths. Right, Ahana? Try. I'll give 2-3 minutes. Let's figure it out. Then I'll solve it. Think whatever you can do. There are N5 that you have to find. Find at least one or two. Just give it a try. Get some water and come. Yeah. Let's see the angles. The first thing, I will choose the whole thing as one system. So if you look at the forces here, this is N1, N3, N5. This is N6, Mg, Mg, and Mg. So in the vertical direction, N6 is equal to 3 Mg. Horizontal direction, N1 plus N5 must be equal to N3. That much I know. That means if I can find at least N1, N5, N3 I can find. Great. And if you look at the angles here, you can clearly see let me show that in the next page. Look at the angles here. So from center to center, if you take this distance, that will be 2r. This distance is r, the radius. This distance is also r, the radius. So from here, if you drop this, this is also r. So this angle theta would be cos theta is adjacent side r by hypotenuse is 2r is equal to half. So that theta is 60 degrees. Yeah. Similarly, if you take center to center here also, you will notice this is also theta. You will notice this is also theta. You'll notice this is also theta. All are thetas. Here also the same logic, that is 2r and this is r. Do have a look at this. So that is the thing about angles. So that is the reason 3r is given. So this is r, this is r. So this balance must be r. All got this? I hope everyone got the angles part. Now let's draw the FBD for each one. Let's draw A ka FBD. This is N1. This is mg. This is N2. This angle is 60. So this would be N2 cos 60. This would be N2 sin 60. So vertically, they should balance out. So N2 sin 60 is mg. So from here, I'll get N2 is equal to 2mg by root 3. Similarly, N1 is N2 cos 60, but N2 is 2mg by root 3, so N1 is mg by root 3. Brute force, you'll start getting everything if I take 1 on FBD. Now I can take only B ka FBD, or I can take A and B ka FBD. So we'll take B ka FBD. It is lengthy, but this would be your N2. This would be your N3. This would be your N4. And this would be your mg. And we clearly see this is 60. This is 60. This is 60. So this component is N4 cos 60. N4 sin 60. This is what I told you in vectors. Resolution of thing is important. This is 60. So horizontal is N2 cos 60. Nothing like brute force solving. You just put the equations and solve. All the forces in the horizontal direction, N3 is balanced by N4 cos 60 plus N2 cos 60. And N2 ka value, I need to find N4 also. What about N4? In the vertical direction, the only guy who's pushing up is N4 sin 60, that is balancing mg plus also N2 sin 60. So N4 will be mg by sin 60, that is mg root 3 by 2 plus N2, and N2 ka value is 2mg by root 3. So this is 4mg by root 3. Now if I know 4mg by root 3 here, I can substitute this. I can get N3 is 4mg by root 3. So take this N4 from here, put it in this. This N3, this is x-axis ka equation. Huh? This is a y-axis ka equation. That would be 2mg by root 3, mg by root 3, 3mg by root 3, or root 3 mg. Once I got N3 and N4, I can calculate from here. So N5 is nothing but N3 minus N1, and N3 is 3mg by root 3. There's no need to draw C ka FBD, you know the overall thing. So N1 is mg by root 3. 2mg by root 3. There, you got everything. Please check this thing. Draw your FBD, resolve the forces, equal horizontal, equal vertical, solve. So the main catch in this question is finding the angle, and taking the overall thing as a system will save you time. That's it. You could have taken A separately, B separately, C separately, and solved it. You would have still got the answer. This question, right? If you had actually taken A and B as one system, your life would have been much faster. Then there is only N1, there is a N3, and there is N4. There's an mg and there's an mg. So N4 ka vertical component is 2mg. N4 ka horizontal component, and N1 is N3. So you would have got it a little faster. But then again, exam mein, we don't know what clicks. Please have a look at the steps. Ask me if you're confused anything. Let's see. Previous slide here.
Yes, sir. Done. Thank you.
Great. Let's see one more. We have a rope here. Someone is pulling with force F. We have a rope here. Someone is pulling with F and F. This is fixed. The rope is at rest, obviously. I mean, nothing is moving. Fixed to wall. So find tension in the strings. If you fix it to the wall, it can't move. If you're applying two forces equally, it won't move. Find the tension in the string. Now, let me ask you one thing. Between A and B, whom you think will have more tension? A or B? Okay, let me ask you other way. How many forces are acting on the first string and how many forces are acting on the second string? How many forces are acting on the first string and how many forces are acting on the second string? See, right area. If I draw the FBD of the first string, what will you see? Force. This is the force due to the wall. Wall is also pulling now. And what is the acceleration? 0 because it is fixed. So F minus F wall is equal to 0. That means the wall is also exerting the same force F. So if you actually think about this, A and B both are identical cases. Sirf in case one, I kept a wall and I hit the force there. You guys are only looking at the force you're applying. You're forgetting the wall is also applying a force. A and B are identical cases. So the only difference is someone is applying a force here. They're behaving like a wall. Getting it? Both of them have two forces acting in opposite directions. Most people think second case will have more tension. Both of them have same two forces. The only difference is case B में external force is there and case 1 में it's a wall. That is one. Next thing. Now, some people say this thing, Tell me one thing. So in case B or case A, what is the tension? Do you think it is 0 or 2F? Do you think it is 0 or 2F? Two F. Okay. Now be careful with this thing. Some people generally think that F and F they'll cancel, so tension is 0. You need to understand tension is not same as external force. For example, if you say tension is 0, if anytime आपको लगता है ना tension 0, think of like this. So if I take you, right, and tie you to one car here and one car here and pull you with equal force, will you feel comfortable? Equal force, huh? They'll cancel out. Na kuch nahi hona chahiye, right? I can tie you to one elephant and pull you apart slowly with equal force. Another, you're getting it. See, someone catches your cheeks and pulls them. You feel that pain and stress. The thing is, tension is a force which comes whenever the body gets deformed. It's like tension is like a resistance in order to oppose the elongation and compression. Tension is not external force. Whenever there's an external force, the body will get stretched or compressed, and the body is fighting back. So think of like that. Tension is a fighting force. It's not external force. So when you pull with F and F, even though the net force is zero, tension is not zero. So how do you find tension? So listen carefully. It is not 2F also. This is quite important, right? Finding tension. This will come in at least 4 chapters. There are like, few chapters where literally it is based on tension. If you know how to find tension, chapter is over. So finding tension in a string or a rod. Step 1. Assume the string is cut at the point where tension has to be calculated. So wherever you want to find tension, assume it is cut there and try to draw an FBD basically, where tension now when you cut it here, now you'll get 2 pieces. So you can draw FBD of any one. In step 3, apply F is equal to MA to solve. Let me show you how it works. Have a look at the steps. Now look at the first part. You attach to the wall. Acceleration is 0 because you're fixed to the wall. You want to find tension, cut it there. I'll get the left piece and the right piece. I'll get 2 parts. Choose any one piece. I will choose the right piece. So that is F. And remember, strings always pull. So this is tension T. And this acceleration is 0. So F minus T is equal to 0. Tension is equal to F. Tension is not 2F. Tension is not 0. Tension is equal to F here. Because if the tension is greater than F, what will happen? The string will start compressing, isn't it? Now, in the second case, you apply F, cut the string here. You'll get 2 pieces. I can take any one piece. Let me take the left piece, so F and T. If I take the right piece, that will be F and T. Acceleration is 0. It is not moving. Same thing. F is equal to T. Both the cases, you'll get tension T is equal to F. Because if the tension is greater than F, logically speaking, the body will start compressing. Matlab, strings is applying too much force than required. Doesn't make sense. Tension ka job is what? If you stretch me, I will try to come back. If you compress me, I'll try to push you back. But I will not apply so much force. Think of like this, huh? If I catch your hands and think of like this, what? If let's say if I'm trying to pull your cheeks, will you pull your cheeks so much that the cheeks will go into your mouth? You just want it to be normal state, right? You don't want them to be compressed also. Are you getting the catch here? So tension is equal to F only. And now people who don't understand this, right? This is how people can get cheated also. So there is a company called Levi-Strauss, Levi-Strauss. Heard about it? Levi's jeans, basically denims. So if you look at the denims, right? These are actually used by industrial workers because the cloth, if you see, it is rough and tough. The denims are actually used by industrial workers in factories. And now it became a fashion and all. So for this industrial factory workers, right, the most important thing is how strong the cloth is. So they don't care about the colors or, the torn jeans or holes in the jeans. They don't want all that. They want strong jeans. So this company, right, the marketing was like this. So they took the denims. They tied one side to the wall and the other side, they kept a horse. And the horse was pulling with full force. And the pant was intact. Nothing happened. When they said like, Dekho, our material is so strong. Even when a horse pulled, nothing happened. Super quality jeans. And people were impressed. Yeah, horses pulling and nothing happened. Matlab, kitna acha hona chahiye. So sales were up. Now next year, what they did, they took the same pant, but this time they kept 2 horses. and the pull with equal force. And now that's a look at this thing. This is our new variation. It's a double strong pant. But tell me one thing, frankly, is it any different than these two problems? It doesn't matter whether you tie to a wall or you put a horse. The tension is the same. But what will people think? Previous one horse. This is two horses. So two horses must be different, right? You get the point. So for people who don't know tension, you will think if there are two horses pulling, you will think that is better than, meaning the pant doesn't care whether there's a horse on the left or there is a wall. Make sense? The tension will remain the same. And that is how, if you know little science and while doing marketing, you can actually cheat people. And you'll say, this pant is double horse pant, but the cost is only 1.5 times. People will love to buy it. Your pant, na, two horses are pulling, but nothing happened. And they're selling it only for 50% increase for double strength. People think it's a bargain. It's a story I heard, and I found a picture also of this. There, that is a band with two horses. Pretty old one. I think 1873 ka ad hai ye. Obviously, right? You go to a shop and you won't ask, na, how many horses can pull this pant? And then you buy it. The salesperson will come and ask, "Sir, exactly what you want to buy." I want to buy a pant which can be pulled by two horses. Looks weird. Clear with this? Any doubts on the steps? So this is how you find tension in anything. Next class we'll do more variations of this, but today strings are not moving. But when the strings move, this becomes pretty nice. Let's see one more. Turn in the page. And this problem only, na? Okay. Let's make a B part of the same problem. So we have two walls. We have a rope here. The rope is like this. This is point B, this is point A, this angle is alpha, this angle is beta. Both the points are not at the same level. The point C is the lowest position. C is a point, is the lowest point of the rope. So if you look at the string here, there will be a tension like this, TA, and there will be a tension like this, TB. Mass of the rope is M. M is the mass of the total rope. I don't know the shape, I don't know the length, I just know the mass. The question is, find TA, tension at A, tension at B, tension at C. Let's get the. So we have a rope hanging between two walls. Both are not at the same level. Huh? Let's get this. This is a good one. Yeah, right, Vihan. Purvaja. No, that's not right, Purvaja. Hmm, yeah, I think so. Let's see. Show you. Let's see. Step 1, draw the FBD. There is only string here. So if you look at the components, this is beta, this is alpha. So the vertical component here would be TB cos beta. Horizontal will be TB sin beta, TA cos alpha, TA sin alpha. The weight of the wire will be mg somewhere here. Yep. And if you see the vertical forces, TA cos alpha, horizontal लिख लेते पहले, TA sin alpha must balance TB sin beta. That is the horizontal forces. And vertically, TA cos alpha plus TB cos beta must be equal to mg. So get TA from here and substitute in this. That would be TB sin beta cos alpha by sin alpha plus TB cos beta. And what I did here, TB sin beta by sin alpha. Take that and dump it here. Is equal to mg. Cross multiply, you'll get TB. This will be sin beta cos alpha. This will be sin alpha cos beta, and that would be mg sin alpha. You can clearly see this is nothing but sin alpha plus beta. Sin A plus B का formula था वो. So we'll get TB is equal to mg sin alpha by sin alpha plus beta. Yeah, TA would be mg sin beta sin alpha plus beta. Check. That's your answer. Options it will be sin alpha plus beta. So you should know that. Matlab, some of you got the answer, but you didn't simplify till sin alpha plus beta. So you'll get stuck there.
Sir, how did you ignore TC?
Why will I take TC? Where is C? What is your system? What is your system? बोलना पूरा. What is your system?
The whole row?
Whole rope. Where is C?
Okay, sir. Okay, sir.
अगर तुझे C लेना है ना तो C पे कट करो. अगर C को कट
Yes,
किया
sir.
then B आएगा नहीं. All clear with this? Any doubts on this? Please check. Now, how do you find C? Now you'll notice something in this string. and this is TA. This is alpha. This is TA sine alpha. This is beta. This is TB sine beta. Now it doesn't matter. You take any point here. If you take tension T and theta, you will get T sine theta. Now if you see at every position, the horizontal tensions are same. So TA sine alpha must be equal to, meaning if I just cut a string like this, meaning depending on which piece you're taking, if you take the left piece or the right piece, you will notice that TA sine alpha is equal to T sine theta. This will be a theoretical question in the exam in more than one choice questions. So on the string, he will say the horizontal component of tension always remains constant. Because think about it, gravity is always down, right? So why will the horizontal forces change? Just like projectile motion, U cos theta is always constant because the vertical forces won't affect anything in the horizontal direction. The same way, the horizontal component of tensions won't change because of gravity. Horizontal component of tension at any point is constant because gravity won't affect the problem in the horizontal direction. Here I took theta with the vertical, इसलिए T sin theta आ रहा है. If I take theta with the horizontal, I'll get T cos theta. Meaning theta will change, T will change, but the product will remain constant. Now, when you want to find the tension at C, now understand one thing, C is the lowest position. That means at point C, if you try to draw the tangent, it will be horizontal. Because that's a turning point. It's a minima. At C, tangent is horizontal. So at point C, tension will be like this. At point A, tension TA is like this. And this angle is alpha. This is TA sine alpha. There you get it in one step. So tension at C is nothing but TA sine alpha. And TA is nothing but mg sine beta. So it will be sine beta sine alpha by sine alpha plus beta. That's your answer. So in this question, they can ask you multiple things. Find TA, find TC, right? Find tension at this thing. 3 tension they can ask you. They can ask you, is the tension while coming from A to C, is the tension increasing or decreasing? So T sine theta is constant. So theta is becoming 0, the tension should increase. So you can play around like that. The horizontal component of tension remains constant. And later on, we will see in work power energy. We will say there is a small ring here which is sliding on this rope. Find the speed when it reaches C. So multiple things we can do. Please have a look at this. It's a good question. This is a good one explanation. So no matter what kind of string you take, kuch bhi string, the horizontal component tension is same. Simple reason, gravity is not going to affect anything in the vertical horizontal direction. Is this clear, everyone? Clear, na, Purvaja? You got it, na? If you want to find C, you have to cut it there. Arnav, clear with this? Taksha? Clear with this? Ishana? Jainil? Niharika? Nikhil? Surya? Vignajit? Perfect. Let's see one more. Let's move things a bit. We have an angle theta. This is a fixed incline. So incline is not moving. Here we have a block of mass m. Height is h. This is a 3.5 turns helix. height is h, radius is r. This is point A, this is B. Here we have a bead. So bead is sliding on the helix. Find the time taken to reach the ground, both the cases. Let's do the A part. Both are connected actually. Find time taken to reach the ground. There, nothing started moving. So next class will be even more fun. And everything I taught you, you know all the basics. Everything I made the things ready, like, you know, all the basics, FBDs, constraints, kinematics. Now it's only a matter of combining. So you'll understand everything, but ideas click nahi hoga. That is because lack of, you know, it'll take time. You have to see some problems. In the class, we will see some 15, 20 problems. And then in the practice, you must do another 100, 120 problems. Physics is clear. Every chapter, you need to handle at least 120 to 150 questions. If you can do, and you covered different models, you'll be able to handle most of the questions. And for max, you have to do at least 300 plus. So every subject is different. Physics, it is more important you do less, but you do a deep thinking, like, okay, what is happening here? Can I do this anyway? Agar block is taraf ne is taraf gaya to kya hoga? Possibilities. Let's do the first part. First part is easy. Step 1, remember the story is the same. Step 1, choose your system, draw an FBD. Step 2, SN accelerations. Abhi karna hai. Block is sliding, so A acceleration. Resolve forces. Right, F is equal to ma. Think for a minute, then I'll show you. Let me show you this. Look at the first part. Step 1, choose your system and draw the FBD. Obviously, my block is the system now, because that is the only one who is moving, which is fixed. Forces. Mg sin theta. Mg cos theta. Normal reaction. Step 2, assign accelerations. Now be careful here. This is the convention I follow. Whenever you draw, write forces on the body, accelerations outside the body. Don't mix it up. Acceleration is this way. Now, in the direction of acceleration, so basically I am choosing this line as my x-axis and that line as my y-axis. So the forces, now here sometimes I see people getting confused, so be careful. All forces in x direction will give you mass into acceleration in x direction. So here all force in x direction is mg sin theta. That is the only force. That is equal to mass into acceleration. So some people I saw, they write like this, you know, they say mg sin theta plus ma is 0. Be careful, ma is not a force. So therefore we got the acceleration a is equal to g sin theta. I know it looks easy, but better to be careful than getting confused later on. You're done, you got the acceleration. This is height h. The block initial speed is 0. This hypotenuse cut distance is h by sin theta. That is your displacement. You know displacement, you know initial velocity, you know acceleration, and you're asking for time. Kinematics. S is equal to ut plus half at square. Everything you learned will pop up. So displacement is h by sin theta. Initial velocity is 0. Acceleration is half g sin theta, and that's time square. Therefore, we get t is equal to root over 2h by g sine square theta. That's your problem. NLM plus kinematics. Do have a look at this. Ask me if you're confused. Yeah, that sine theta comes out, it becomes cosecant theta in the numerator, but all clear with this? Anything you're not clear in this, please ask me. Now, if you're clear with this, question is not over. The main question is this helix. Now, if the bead is sliding on the helix, how will you play with this? Any doubts on the incline, please ask. Incline is clear. Let's get the helix. Try. I'll give you 2 minutes. And I hope you remember what is a helix. If you take a rectangle and if you draw a diagonal and if you fold it, you get a helix. And if you're shaking your head right and left and you forgot, that means you're not bothered to revise the notes. So that's what happens when you don't revise the notes. Everything that you learn will keep popping up. You will slow down because you're bad at revising the notes. Where we have done this here? We did it in quite detail. Page 7. We had a full discussion on this. I taught you 4.5 tons helix. Here I gave you 3.5 tons helix. So that's page 7. You can refer for more about that. Think. Take a minute. So that's the main idea. If you know what a helix does, becomes straightforward.
Sir, U0 here.
Initially starting from rest. See, the idea here is, if you take a rectangle and if you draw a diagonal and if you fold this into a cylinder, that is what you get a helix. This is a 1-ton helix. So if this is height h, this is also height h. If this is radius r, so this is 2 pi r. So indirectly, every 1 turn will be 2 pi r. Now look at our problem. So what I'll do for convenience, I'll just name these points. Let's call it A, C, D, E, and this is B. Now, when I make a rectangle out of this, so this is A. So when you go from A to C, remember 1 turn is completed. So for every 1 turn, you will travel a distance of 2 pi r. So when you go from C to D, you completed 1 more turn. So from C to D, again, another 2 pi r. From D to E, again 1 more turn, another 2 pi r. From E to B, it's an half turn, so that is pi r. That means this total horizontal distance is 7 pi r. And this height is h. Now, when this bead is sliding here, see how it looks. So this bead here, which is sliding, isn't this how the bead looks like here? It is sliding. When it is sliding on the bead, it is as good as sliding on an incline. So when the bead is here sliding, it feels like the bead is here sliding. So the motion on an helix is similar to the bead block sliding on an incline. Motion of the bead on helix is similar to motion on incline. So for this incline, the height is h, the base is 7 pi r, this is theta, so this is root over h square plus 49 pi square r square. So this will give you sine theta is equal to opposite side by hypotenuse. Now, if this is exactly like the previous question, there is no need to do again. Then I know the time ka value is root over 2h by g sine square theta. Is that making sense? So the whole question is finding theta. Once you do that, it is same as question A. That's why I kept both the questions together. It must have looked odd, like how they both are connected, but now you can see. Is this making sense, everyone? Helix, I think, is the third time you're seeing this already. Get used to it. In case you forgot, do make sure to go back and revise the notes. There, now we started moving things. So next class, we'll move even more things. It will be now much better. But I hope you can see now what I was trying to do in the beginning. So, I taught you FBDs, constraints, then equilibrium. So by now you got used to writing FBDs, you got used to writing accelerations. Main thing is that you need to get used to it. So once the subject matures, when the questions become tough, you'll be able to handle. But if you had started directly with this, I start with the problem. In the problem, I teach you FBD. In the problem, I teach you constraint, everything in one go. It becomes a khichdi. Anyways, so that's the last one for the day. So I hope everyone has resolved the paper. So do solve it. We can discuss that on Thursday. But paper was easy, right, this time? Yeah. Okay. So we'll wind up for today. So we'll catch up on Thursday, as usual again. So any doubts, anything, you can stay back and ask. Also free to leave. So paper ka doubts, we'll see it on Thursday.